Okay, so starting down here with the graphing ones, and then we'll work our way up. Down here it says triangle ABC has these vertices, and it says complete this statement to best classify ABC. The answer choices for this are, they are either scalene, so that would be all sides different lengths. Isosceles, that would be two sides are the same length. And equilateral, so that would be all sides the same length. So that would be the options for this drop down here. I'm going to zoom in. And then for the second one, the options are either right, acute, or obtuse. Thank you. So the three options, scalene, isosceles, equilateral, or right, acute, or obtuse triangle. So right triangle would have one right angle, acute would have all acute angles, and then obtuse would have one obtuse angle. And of course, these words are on the study guide too. So like, yeah, just to be thorough. Okay, you may have already graphed this shape, but I'm going to graph it here for those that haven't graphed it yet. Let's see, trying to get it all to fit on the screen. Okay, so graphing these points, A is at 1, 1, so that'd be A. B is at -2, 1, 2, 3, 4. And C is at 1, 7, 1, 2, 3, 4, 5, 6, 7. C, right here. Okay, and then use your ID, or if you have a straight edge of some kind, to draw the triangle. The more accurate your drawing is, the easier answering the problem will be. Yeah. So here's my triangle. So as far as whether it's scalene, isosceles, or equilateral, I can see it's not equilateral. This side is definitely longer than the other two, so it's not going to be equilateral. It's between scalene and isosceles. So what I want to do is see if AB is equal to BC in length, like is this equal to this? And if it is, then it would be isosceles. So I want to find the length of AB. And the way I would find the length of AB is like I would maybe use Pythagorean theorem and like 3 units by 3 units. I can do 3 squared plus 3 squared equals C squared. 9 plus 9 equals C squared. 18 equals C squared. And I can just leave it like this. So the length of this is 8 square root of 18. So I'm trying to figure out if it's isosceles. And then I need to find the length of BC. So the length of BC here, and again, I can use Pythagorean theorem to find this length. It's 3 units by 3 units, so at this point, it's pretty clear. 18 equals C squared, square root, and this is equal to square root of 18. So I could solve this out to a decimal, but obviously square root of 18 equals square root of 18. So these two sides are the same length, and so therefore, yes, isosceles. And then for this blank right here, ABC is an isosceles is what you would choose. Okay, and then I have to determine whether it's right, acute, or obtuse. There's different ways that I could figure this out. One way is like acute triangles, A squared plus B squared would be greater than C squared. Obtuse triangles, A squared plus B squared would be less than C squared. And then right triangles, A squared plus B squared equals C squared. That's one way I could figure it out. Another way that might be even easier would be to look at the slope. So slope of BC and slope of AB. If these are perpendicular, that would mean that this is a right angle, and that would mean that this is a right triangle. So if I find the slope and the slopes are negative reciprocals, so I'm looking at if the slopes are negative reciprocals. So like example would be like 2/3 and -3/2. Like these are negative flips of the fraction. And if that happens, then these are perpendicular and it's a right triangle. So slope of BC, and I can just look at the graph, up 3 over 3. So 3 over 3, which equals 1. And now I need to find the slope of AB. And again, if you're doing this on the test, you wouldn't really need to write down like every little thing. It would go a lot faster. I'm just trying to show the steps visually as well as talk about them. So the slope of AB here, it's down 3, so negative 3 plus 3 this way. So negative 3 over 3, which would be negative 1. So I was looking for these to be a negative flip. Well, 1 over 1, a negative flip to that would be negative 1 over 1. So yes, BC is perpendicular to AB, and that means that it's a right triangle. Right triangle. And then fill in right here. Then maybe make a note that the work is on the graph. Okay, then the next one. Okay, the next one down here, it says the vertices of the quadrilateral are this. Quadrilateral would be four-sided shape, 4 sides. Complete the statement to best classify the quadrilateral. Oh, sorry, I didn't realize it wasn't the script. The options, the choices are trapezoid, isosceles trapezoid, and again, these are all on that study guide, so as you go through, make sure that you know each one just in case. Rhombus, parallelogram, rectangle, and square. So trapezoid looks like this. Isosceles trapezoid, 2 sides are equal like that. Rhombus kind of looks like this, and all the sides are equal. Parallelogram be like this. Rectangle with 90-degree angles, and then a square, all the sides are equal, and then 90-degree angles. Okay, so when we graph it, we're trying to figure out which one of these shapes it is. So I'm going to kind of fold my paper so it fits in the frame. Here. Okay, graphing these points. A is at -3, 1. A. B is at 4, 2. C, 9, -3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oop. -3. Just barely fits. And then 2, 1, 2, 3, 4. Okay, then connecting my dots as best I can. Then the more accurate, the easier it'll be to figure this out. Okay, and then once you have it graphed, you're definitely narrowing down answers. Like there's a lot of things this can't be. It's not a square, right? It's not a rectangle. It doesn't have 90-degree angles. It could be a parallelogram, like opposite sides parallel. It could be a rhombus, just based on the pictures I even drew. Trapezoid, definitely not, and definitely not isosceles trapezoid. So it's between these two answers, rhombus and parallelogram. A rhombus and parallelogram, they both have like opposite sides parallel. The difference between a rhombus and a parallelogram are that a rhombus, like all the sides are the same length. So to verify that it's a rhombus and not a parallelogram, I'm going to find the length of each side. And again, I'm going to simplify the process, and then if all the sides are the same length, then it's a rhombus. So the way I would find the length of this side is just use Pythagorean theorem to find it. So here I have 1, 2, 3, 4, 5 units by 5 units. So that would be 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. 50 equals c squared. Square root both sides, and we get square root of 50 for this length. Did I simplify that? Yes, but it's not needed. Then for this side here, 1, 2, 3, 4, 5, 6, 7 units by 1 unit. So 7 squared plus 1 squared equals c squared. 49 plus 1 equals c squared. So I get 50 again. Square root of 50, square root of 50. So this is square root of 50. So if you were to count this out, it's 1 by 7, which would solve to this. And if you were to count this out, it's 5 by 5, which would give you square root of 50 here. So all the sides are the same length, so therefore it is a rhombus. Rhombus. Okay, those are the two longest ones, and the rest go really fast. I did the longest ones first. Okay, next, level 1. So these are the easiest style questions that you could get. Some of your goals, of course, is to pass the EOC, but then some of you are going to be just to improve the scale score or the level that you're at. So just keep that in mind as we go through this. So here it says select the correct response from the missing reason of the algebraic proof below. It says the given is this equation. And remember, given always goes in that first statement. So they already filled that in. And now they're just solving it, and they're just naming the reasons or like how they're solving it. So from this step to this step, they're distributing this 2 to both of those terms. So the reason would just be distributive property of equality to get to that step. Then from there, they combine like terms. So 3x minus 2x is x, and they put combine like terms, simplify. Then from this step to this step, they added 2 to both sides, so that would be addition property of equality. To get this right, you only needed to fill in this. However, just kind of showing you the different ones, because on the test, they'll probably give you something a little bit different. Okay, then over here, it says in this image, M is parallel to N because 4 and 6 are blank blank angles. They are blank. Okay, so 4 and 6, I'm going to find them. 4 and 6 are alternate interior angles. Alternate interior angles. They're on alternate sides of the transversal and on the interior of the parallel lines. And they are congruent. So alternate interior angles are congruent. You might want to also like contemplate how else they could ask this. So they might ask about like corresponding angles. This would be corresponding, which would be equal. Or they could ask about alternate exterior, like this. Which would be equal. Or the other one that comes up is consecutive interior. It should be like here and here. Consecutive interior angles. And consecutive interior equal to 180 degrees, or they're supplementary. And again, I put those on the study guide too, so you can look at each one. Okay, then this one here. It says in the figure AE is parallel to BD, AC bisects BAE. So this word bisects BAE means that it cuts this angle exactly in half, and these two angles are identical in measure. What is the measure of BAC? So we're trying to find this angle right here. Okay, so there's different ways you can go about solving this. I'm just going to go with what we know. We know these are parallel. We also know that alternate interior angles are equal. So if this is 62 degrees, so is this. We also know that all three of these angles would add to 180 degrees because they form a straight line. So we can do 180 minus 62 equals 118 degrees, and 118 would be both of these angles combined. And then from here, since these are the same measure, we can do 118 divided by 2 comes out to 59 degrees. And so this would be 59, and this is 59, and this is the one that we want, so 59 degrees. Kind of like a puzzle. For these kind of questions, it would probably be best to draw it out on a piece of paper and label it, because then you can figure it out. Okay, then over here, it says, given that L is parallel to M and N. So all these are parallel, and then you have like two transversals here. It says that angle N, or angle 3 is congruent to angle 2. Angle 3 is congruent to angle 2 because they are corresponding angles. That's a popular word on testing, corresponding angles. And then it says that angle 1 is equal to 2 because they are vertical angles. Another very popular word, vertical angles. Vertical angles are opposite each other. And then the last statement, it says that angle 3 is equal to angle 1. Well, if 3 is equal to 2 and 2 is equal to 1, then 3 must be equal to 1 because of transitive property. Transitive property, when I explained it like the first time, I said, okay, if Lucia's the same height as Scarlett, and then Scarlett's the same height as Riley, then Lucia must be the same height as Riley. And that's what transitive property is. It's very popular on testing, so make sure you know that one. So transitive property is that, okay, if A equals B and B equals C, then A must equal C, like that. Okay, and next, down here. Okay, so in this diagram, A, B, C, D, F, this squiggly line here, what does the squiggly line mean? The squiggly line, just to remind you, means that these are similar to. These shapes are similar, meaning that one's like bigger than the other, but they're proportional. Proportional. Proportional means that they're related through some scale factor. So like, I could do like 6 times 2 or this times 2 or so on. But I need to look at corresponding parts because I might be matching up the wrong parts. So what you need to do is look at this similarity statement and say which part does AF correspond to on this trapezoid here. So let's see. AF is the first and last letter here. So that corresponds to VZ, first and last letter here. So this must correspond to this. So it's kind of backwards from what I was originally thinking. And then here, CD, what does that correspond to? The middle two letters correspond to WY over here. And so now I need to set up a proportion to solve for y. So I'll do red to red. So 12 over 3y minus 1, like the first to the second, equals 9 over 6. And then from here, I can solve for y using cross multiplication. So cross multiply like this. And 12 times 6 is 72. 9 times this, 9 times 3y minus 1. And then I can solve. So 72 equals, distribute this, 27y minus 9. Add 9 to both sides, we get 81 equals 27y. Divide by 27, and y equals 3. Okay, and then the last one on the page right here says ABC goes through a transformation. A transformation is when you move the shape on the graph. You could either slide it, rotate it, reflect it, dilate it, and it shows the result is ABC prime. So the original right here, and then ABC prime is the new one. To go from this shape to this shape, it's not a reflection over the axis. Let's see. It's not a slide because it changes orientation. It is definitely a rotation. So to go from here to here, ABC is rotated to form ABC prime. This can be written as xy becomes blank. So it's asking about the coordinate rules. Okay, so you might have the coordinate rule for 270-degree rotation memorized, but if you don't, you can just use the coordinates that they gave you. So A is at 3, 5, B is at 4, 1, and C is at 2, 1. And then ABC prime, A prime, B prime, C prime. A prime is at 6 or 5, negative 3. B prime is at 1, negative 4. And C prime is at 1, negative 2. So I use these coordinates to figure out the coordinate rule. So xy becomes, and just looking at the pattern, like this goes now into this spot. So the y becomes in this location, and the x goes over here, and it looks like the x is turning negative. So this would be negative x right here. So then here's my rule, and y negative x like that. Okay, that is all for today. So now we're going to transition over to this study guide.